Hello friends. Now the purpose of this video is to make the students aware about some fundamental questions in structural analysis which can be asked during your interviews. I am Dr. N.S. Naik from the Department of Structural Engineering, Sanjeevani College of Engineering, Kopargaon. So to begin with, let us start the first question. Which of the following is a determinate structure? Now here some options are also given. Like first option is two hinged arch, fixed beam, double overhanging beam and continuous beam. Now the correct answer of this question is double overhanging beam is a determinate structure because we can analyze the beam using three equilibrium conditions. So we will discuss one by one. In case of a two hinged arch, if we consider arch having hinge support A and hinge support B, this is two hinged arch. So there will be two reactions at each support. First one is vertical and second one is horizontal. So total number of reactions in case of two hinged arch is 4 and we are having only three equilibrium equations with us. So using three equilibrium equations we cannot calculate the four unknown reactions and hence two hinged arch is indeterminate structure. So this option is not a correct answer. Second option is fixed beam. In case of a fixed beam, we know fixed support it offers three reaction components. Suppose this is a fixed beam and there are two fixed supports. So there will be three reactions at left hand support and three reactions will be there at right hand support. So total unknowns are 6 while again we are having only three equilibrium equations available with us. So using these three equations we cannot calculate the six unknown reactions and hence fixed beam is a indeterminate structure. So these two options are not a valid answer. Double overhanging beam. For example, let us consider a beam having overhang to the left of support and the overhang to the right of the next support. So this type of beam we can analyze using three conditions of equilibrium alone and hence this is a determinate structure. Here we can calculate the support reactions applying first condition summation fx is equal to 0, second condition summation fy is equal to 0 and the third condition summation m is equal to 0. And after finding the support reactions one can easily plot SFD and BMD for such type of overhanging beam. So this is the correct answer, double overhanging beam. And of course we will consider about continuous beam. If a beam is continuous like this having number of supports, so here we cannot calculate all the reactions using conditions of equilibrium alone and hence continuous beam is an indeterminate structure. Continuous beam is indeterminate externally, but if we calculate the reactions, easily we can plot the SFD and BMD. So continuous beam is externally indeterminate but internally determinate because we can calculate the internal unknowns, namely shear force and bending moment. But here the correct answer is double overhanging beam. Double overhanging beam is a determinate structure. Next, if we use link or link support in a structural system, then how many unknowns would be there? Again, the options are given, but you have to simply, you cannot write the option. Okay, this is correct option. You have to justify your answer in few words. So, in case of a link support, so here in this figure, support A is a link support. So this is break line. Support A is a link support and this is link of a structure connected to A. Now for equilibrium of joint A, there must be an equal and opposite force which must be offered by A and that is nothing but reaction at A. So obviously to maintain the equilibrium of this member and the joint, there must be a single reaction which is acting along the line of action of the member connected at link support. So link support offers only one reaction. So there will be only one unknown in case of a link support. Let us move to the next question. Which of the following material is not used in making trusses? Friends, we know members of a truss are subjected to axial forces, and the forces may be either tensile in nature or compressive in nature. And we know metal bars are strong in tension, they can resist the tension. Similarly, wood can resist the tension, channel sections can resist the tension. But when we talk about concrete, we know concrete is very strong in compression, but it is weak in tension, and hence we cannot use concrete in making the trusses. If we use it, it will fail in tension, and that's why the correct answer of this question is concrete. We cannot use concrete in making the trusses. Let us move to the next question. In this question, a figure of a truss is given. We have to calculate the force in member BC. This is member BC. BC of the truss shown in figure. Now we know we can calculate member forces in a truss using method of joints as well as method of sections. But before applying the method of sections or method of joints, we have to calculate the support reactions. Without that we cannot calculate. In case of cantilever truss, we can start from the free end, and then we have to observe the truss carefully, and we have to apply conditions to identify zero force member. To identify zero force member. So there are two conditions to identify zero force members. So first condition is if two members are connected at a joint and that joint is not carrying any load, and the members are non-collinear, then the forces in both the members is equal to 0. And the third condition is if three members are connected at a joint like this, of which two are collinear and there is no force acting at the joint, then the force in the third member is equal to 0. So this condition is applicable for three members connected at a joint. Here we are interested in BC only. BC is connected to joint B, and at joint B the second member is CD. So here our first criteria, this joint satisfies our first criteria. If two members are connected at a joint and joint is not carrying any external force, then force in each member is equal to 0, and hence answer of this question is BC is equal to, force in member BC is equal to 0, because BC is a zero force member, as well as force in member CD is equal to 0. So in this way we can answer the question. No need to solve the problem using either method of sections or method of joint. Let us move to the next question. Calculate the kinematic indeterminacy of the following pin jointed plane frame. So this is the pin jointed plane frame is given. We have to calculate the kinematic indeterminacy. We know kinematic indeterminacy means the number of joint displacements. The number of joint displacements. Now in this figure, the truss is supported by hinged support at one end and a roller support at another end. This is roller support. And in case of a truss, we are ignoring the rotations. We are ignoring the rotations, and we know hinge support. This is the hinge support. Hinge support in a pin jointed plane frame does not offer any degree of freedom as rotation is not considered. So this joint cannot move either in horizontal direction or in vertical direction. Okay, but the roller support is offer a single degree of freedom. This roller can move in this direction because there is no restraint in this direction. So this is 1 degree of freedom. Now let us calculate the number of joints. How many joints are there? So there are number of joints. Joint number 1, this is joint number 2, this is joint number 3, this is joint number 4, this is joint number 5, and this is joint number 6. There are 6 joints, and we know in case of a plane truss each joint offers 2 degree of freedom. Means if we consider a joint, it offers 2 degree of freedom. Means it can move in vertical direction or it can move in horizontal direction. So these are the freedoms. So 2 freedom per joint is there. So there are 6 joint. 6 into 2, 12, plus 1 degree of freedom is there at roller support, and hence total degree of freedom is 13, and hence the degree of kinematic indeterminacy for the given truss is equal to 13. This must be the answer. Next question is, at a fixed support of a beam, both displacement as well as slope is 0. Why? Friends, here we can use the cause effect relationship. The cause effect relationship, it states that when you apply a force, displacement is bound to be there. When you apply a moment, rotation must be there. This is called as cause effect relationship. While in case of a fixed support, here this is a fixed support. In case of a fixed support, it offers three reaction components. It offers three reaction components. First component is vertical reaction. It means that the support cannot move in vertical direction because force is there to avoid that displacement. Similarly, it can offer reaction in horizontal direction. So reaction is nothing but a force. So when we apply a force, we can avoid a displacement also. As force causes displacement, to avoid the displacement, we have to apply a force. In reverse order, it is true. If you want to avoid a rotation, you have to apply a moment. Or when you apply a moment, rotation is there. So in both direction, the cause effect relationship can be applied. So because of this horizontal reaction, there will be no horizontal movement of this support. Okay, and it offers a moment. When the support is offering a moment, there will be no rotation, and that's why due to presence of vertical reaction and moment, there won't be any displacement and slope in case of a fixed support. This is the justification of the statement. Now next question is, which structure will perform better during the earthquake? The number of options are given: statically determinate and indeterminate structure. It depends upon magnitude of the earthquake, only statically determinate structure, or statically determinate structure. So first option is both statically determinate and indeterminate. Second is it depends upon magnitude of earthquake. Third one is statically indeterminate. Fourth one is statically determinate. So which type of structure will perform better during the earthquake? Friends, the statically indeterminate structures has a tendency to redistribute its load due to its redundant supports in case of overloading. Now overloading means when earthquake takes place, additional load is applied or is acting on a structure. So when additional load acts on a structure, and if a structure is having redundant support, so that structure, indeterminate structure, it redistributes the additional load to its redundant supports, and hence it performs better during the earthquake. So our answer is statically indeterminate structures perform better during the earthquake because of its tendency to redistribute the additional load. Next question is, the beam shown in figure carries loads of 20 kilonewton and 40 kilonewton at point C and D, and it produces a deflection of 6 mm at point E. So when we apply 20 kilonewton and 40 kilonewton load on the beam, definitely the beam will deflect like this, and there will be deflection at point E, and that deflection is given as 6 mm. To produce a deflection of 8 mm and 5 mm at point C and D respectively, the load required at E would be, means if we apply first set of load of 20 kilonewton and 40 kilonewton as shown in the figure, it will produce a deflection of 6 mm at E. Now the question is, what load is required to be applied at E to produce deflection of 8 mm and 5 mm at C and D. So friends, here we will use the Maxwell-Betti theorem. The first I will read the statement. Betti's theorem, also known as Maxwell-Betti reciprocal work theorem. We know work means force into displacement. Work means force into displacement. S. This is for displacement. Maxwell-Betti reciprocal work theorem. It is discovered by Enrico Betti in 1872. The theorem states that for a linear elastic structure subjected to two sets of forces Pi and Qj, the work done by the set P through the displacements produced by set Q is equal to the work done by set Q through the displacements produced by set P. And this theorem has applications in structural engineering where it is used to define influence lines and derive the boundary element methods. So according to Maxwell-Betti's theorem, now the work done by 20 kilonewton force is 20 into displacement, means 20 into 8. The work done by 40 kilonewton force is 40 into 5. And this work done must be equal to the load which we apply at E, say W. So W is the load, second set of load applied at E. So work done by W is equal to magnitude of load, that is W, into deflection produced by the set P. So this is set P, this is set P, and this is set Q. So work done by set P is equal to work done by set Q in short. So 20 into 8 plus 40 into 5 is work done by set P must be equal to work done by set Q. Set Q is W into 6, and hence magnitude of force or load which is required to be applied at E would be equal to 60 kilonewton. This is the explanation of uh, the answer 60 kilonewton. Why 60 kilonewton? And the next question is now calculate the K value of the member BC. Calculate the K value of the member BC. This is member BC for the given external redundant truss. This truss is externally redundant because it is supported on hinge support at A. So there will be two unknowns at A. There will be two unknowns at B. So thus four unknown reactions are there, and we are having three equilibrium equations, and hence the truss is externally redundant. So again I will read the statement. Calculate the K value of the member BC for the given external redundant truss considering the horizontal reaction of support B as redundant force. We are studying analysis of indeterminate trusses. If the truss is externally redundant, then we have to select the redundant force and we have to replace that redundant force by a unit load at and corresponding to that redundant, and then we are analyzing the truss. Of course during that we are uh, removing the external loads, and this is called as K analysis. So during K analysis what we are doing, we are applying unit load at and corresponding to the redundant. So here the truss is externally redundant and horizontal reaction at B is considered as redundant, and therefore we will apply unit load at and corresponding to B at support B at and corresponding to the redundant. Redundant is horizontal reaction at B. So unit load is applied at B. Now when we apply unit load at B, you can notice that force in member BC is equal to 0. Why 0? This is the explanation. If the support reactions at support is considered as 1 kilonewton rightward, the horizontal force at the joint will be balanced by horizontal force in member AB. Now this member AB will balance this external force, And since all the external loads are removed, there will be no reaction in horizontal direction. And hence, to balance this 1 kilonewton force, AB must develop a 1 kilonewton internal force, and thus the joint B can be maintained in equilibrium, and hence the force in member BC is equal to 0. Friends, here we can apply the condition for which we have already used in identifying the zero force member. Here this is as good as a member force 1 kilonewton. This is as good as a member force 1 kilonewton. So here member AB, this is force in member AB, this is horizontal reaction, and this is force in member BC. And we know when three members are connected at a joint and joint is not carrying any external load, then the force in the third member is equal to 0 provided the two members are collinear. So here force in member BC is equal to 0. Now this is the last question. Members of a stresses are subjected to which type of force? We have already discussed when a truss is loaded, the members are subjected to axial forces only, and that force may be axial tension or axial compression. So no further discussion is required for this answer. So these are the fundamental questions which you must know when you are preparing for your interview as a structural engineer. Thank you.